Alright, welcome back to another video on my channel, math_exe. And today we're going to look at some interesting facts about like slopes of some, I would say, special lines. And what I mean by those special lines are horizontal lines and vertical lines. So what I think is interesting is there is like a fixed formula for the slope of each of these lines. So we're going to find the slope of each of a horizontal and a vertical line using our formula for the slope. So I just rewrite that. So m equals delta y over delta x, and some people would call this rise over run. That's just another way to interpret it. So, and you can just say this is equal to y2 minus y1, the change in the y direction, and we have x2 minus x1, which is the change in the x direction. Okay, so first we're going to find the slope for our horizontal line right here. I'll just call this line, actually I shouldn't write, so I'll just call this f of 1. So first we need to take like two certain points on the line. So we have, let's just say the points right here, and I'll just call this point A and point B. And since this is the horizontal line, that means the y coordinates must be the same. So we'll just assume the coordinates of A will be x1, and we'll just say a certain constant, let's just say small a. And for the coordinates of B, we'll just say this is x2, and since they are both in a horizontal line, therefore their x coordinates must be the same. So we'll just rewrite this like so. And plugging in our values to our formula right here, notice our y2 is, let's see, a, and our y1 is a as well. x2 minus x1 is just the same right here. And notice a minus a is 0, so I'll just write this. This is all equal to 0, and 0 divided by anything is just 0. So yeah, it doesn't really matter which points you pick for our slope formula, because it always gives us a slope of 0 right here. And next we're going to find the slope of the vertical line. We can just do the same thing right here. So let's see, we're going to have two points right here. We'll just call this point C and point D. I'll just erase my writing right here. And since I don't want you guys to be confused, I'll just call this M1, which is the slope for the line of F1. And likewise, we're going to call this F2. So using our formula above, we have M2, which is equal to, well, I should have written the coordinates of C and D first. And notice they're in the vertical line, therefore their x coordinates must be the same. So let's see, we're going to use small b, and we're going to have y1. And we have D, which is B, because their x coordinates are the same, and then we'll have y2. And just plugging into the formula, we have y2 minus y1 over x2 is b, x1 is b. And notice this whole thing is 0, and you can just look this as, so I'll just rewrite this on the side right here. So we're looking at a number which is, I would say, relatively big compared to 0, and then divide by 0. So something big divided by something small, and if you think about it, it will result something big, and it will be so big that it will approach infinity. And some people would call this infinity as undefined because anything divided by 0, it's pretty much broken right there. It kind of like breaks everything, I guess. So we can just say this: the slope of a vertical line is undefined, or it's infinity. So either way you want to say it, it will be still right. And one thing I want to mention, I'll just redraw the xy plane right here. If you have two lines with the same gradient, therefore the slope is the same. So let's see, we're going to say this right here. So it doesn't matter where the y-intercepts are, as long as their gradients are the same. We call this line L1 and this line L2. We can say that L1 is parallel to L2. And what I mean by parallel, that means if you extend both lines in both directions, either this way or this way, both ways, they will never intersect each other exactly once. And you can just show that by forming a system of equations. So let's see the equation of line 1. Let's say it's mx plus a. Equation of L2 is mx, the gradients are the same, plus b. And then you can just set all this equal to each other. And then you can notice that we can subtract mx from both sides, and this will cancel. And this will leave us a equals b. And this only is true if a is equal to b, which means the y-intercepts are the same. So if I redraw that, it will just look like this. It will just be on the same line. So that doesn't really that is not really interesting. So we can just say if their y-intercepts are different, and if we want to find the point of intersections, then we cannot, because we have contradicted that if a cannot be equal to b, and therefore they are parallel to each other and they will never intersect at a certain point. Okay, so enough for those fun facts. I'll just jump into a example question. So let's see. I'm going to draw an xy plane right here, and this question contains some several parts. So for part A, we need to draw the line y1 is equal to 1/3x plus 2. And I would say this part is pretty simple. You can just plug in some certain values of x. Actually, what I mean by certain is just two certain points, certain values of x, and then you can get the separate y values of that. So yeah. So let's see. So what x values we're going to plug in. So let's say we're just going to set the symbol x equals 1 and x equals 3. Let's just say you can just choose any certain point if you want. So yeah. So for x equals 1, our y1 value, it will be 1/3, since x equals 1 right there. And this will give us the coordinates to 1/3. Let's separate this right there. And for x equals 3, our y1 value will be 1/3 times 3 plus 2. Okay, and notice this 3 and this 3 will cancel, leaving us with a 1. So we only have 1 plus 2, which is just 3. So given our two coordinates right here, so we have our first point 1, 2, 1 over 3, and then we have 3, 3. So we can just plug in those points in right here. And of course I'm in my iPad, so this will be pretty difficult. And of course this won't be precise than in pencil and paper, so yeah. You can just try to draw this on your own and see what line it is for you. So I'll just mark this 1, 2, 3, and point 1 to 1 over 3 is approximately right here, and point 3, 3 is right here, and then you can just connect the dots and just form a straight line. And mine isn't as accurate though, so yeah. Okay, and that's pretty much it for part A. So I'll just rewrite the part B. Okay, so we'll just say given another line y2 is equal to, let's see, 3x minus 1, and we need to find the point of intersection of these two lines. I'll just put right there, right there. So what does this means is we need to find a certain point right here, right on this line, which intersects y2. So we need to find a point where y2 intersects y1 or vice versa. So this is pretty simple. You can just simply just set these expressions both equal to each other. So we can have 1 over 3x plus 2 is equal to 3x minus 1. And this is just a simple linear equation, and you can just work things out quite a bit. So I'll just write the steps for you guys. So we're going to subtract by 1 over 3x on both sides, so you can eliminate these terms right there. So we only have 2 on the left hand side with 3 minus 1 over 3x. Well, if you think about it, it will be just become 2 over 3x. However, I would probably just set this into an improper fraction just to make things way easier. And after this, you can just add 1 on both sides. This and this will eliminate each other. So we're left with 3 is equal to 8 over 3x. And then you can just multiply by the reciprocal of 8 over 3, which is just 3 over 8. And there we go. So this and this will cancel, and there we go. So for x coordinate of our point of intersection will be x is equal to 3 times 3 over 8, which is just 9 over 8. And how to find the, what do you call it? How do you find the y coordinate, you may ask? Well, you can just simply substitute it into one of these expressions. It doesn't really matter which one, because we know this, we just set these to be equal to each other, so we just plug into this one. So we have 3, our x value before 9 over 8, f minus 1. So our y coordinate will be 3 times 9, 27 over 8. We'll just set 1 become 8 over 8, and this will simplify to become 19 over 8, just like that. And if you did your calculations correctly, in theory, if you plug in the x value into this equation, you will get the same result. So yeah. And coming back to our question, we need to find the point of intersection. We can just write this in coordinate form. we have our x coordinate, which is 9 over 8, comma our y coordinate, which is 19 over 8. 19 over 8. And you may interpret this in another way. You can just draw the graph 3x minus 1 on here, and if you did everything neatly, you may find the point of intersection. Alright, so I'll just go in another example of a question. Two equations, and although it might seem complicated, but we're also given another clue. y1 is parallel to y2. Okay, so for the first part A, we need to find the value of A. And for the next part, we're given that y2 intersects the y-axis at 0, let's see, 19. So given this clue, we need to find P. So even though these look pretty difficult, I guess, but if you think about it, given my last video, I have talked about the points of formula, which is we just write here, y equals mx plus b. And notice these coefficients look similar to each other. Now just write this another one right here. But since we already used b, we'll just use c. And notice since y1 is parallel to y2, therefore the slope must be equal to each other. So we can just set up an equation in terms of a. So we have 1 over 3a. I'll just write the whole thing right here. Okay, and we have set up our equation exactly what we wanted to. We can just solve this. So I'll just add 8a to both sides right there. So in this will cancel. I'll just set this into an improper fraction, so if we think about it, it will just become 25 over 3a plus 8. This will equal to 2. And then we can just subtract 8 from both sides. We have 25 over 3a is equal to 2 minus 8, which is negative 6. And then we can just multiply by the reciprocal of the coefficient of a, which is this thing right here. So notice 3 will cancel, 25 will cancel, and don't forget we need to do the same thing right here. And left out by our final answer, our a value will be equal to negative. I'll just put the negative all the way into the front. We'll have 18 over 25. There we go. This is our answer for the A part. And for the B part, we're given y2 intersect the y-axis as at 0, 19. And return to our points of formula, our B, or in this case our C, because we're talking about y2, this C stands for y-intercept. Well, for our coordinates right here, the 0 doesn't really help because it's pretty obvious where it intersects. However, this 19, this C must be equal to 19, and therefore this C must be equal to this. So we can just set P minus 15 equals 19. So we can just write our B part. And I will just indicate this for A part. in our B part, we'll just set up the equation. So P minus 15 is equal to 19. Let's see if I get it. Yep. Okay, and this is pretty simple. We can just add 15 to both sides and we'll just get the answer right away. This and this will cancel. Get P is equal to 19 plus 15, which is 34. And this is our final answer for the B part. And that's it, I guess, for all the examples that I wanted to give you. So hopefully guys you enjoy this video. Please subscribe for more videos, and I'll see you guys in another video.